Alright, it says the figure shows the graph of y equals 1.2x minus 0.36, and we're supposed to do parts A, B, C, and D. So let's go to part A. Again, this is an equation in part A that I could solve by hand. I would just add 0.36 to both sides and then divide by 1.2. That would be doing it algebraically, but instead we're going to do it here graphically. So it says this equation, which is really my y, because notice y is equal to that expression. So what this is really saying is it's saying y is equal to this 0.6. So I go to my graph and I find where 0.6 is on my graph on the y-axis. Right here is 0.6, and then I get to my red line, and here's what they're interested in, this point right here, which has an coordinates 0.8 down here for the x and 0.6 for the y. So when is y, or 1.2x minus 0.6, equivalent to 0.6? Well, that occurs at the x coordinate 0.8. So that's part A. All we have to do is just find the x coordinate. Same thing for part B. We have when is that y, remember this was our equation y, equal to negative 0.6. Well, I just go down here below and I find negative 0.6 right here, and I jump to my graph, and here is the action point. X coordinate happens to be negative 0.2 and y coordinate negative 0.6 as they gave us. So when is the y value equal to negative 0.6? Well, on my graph, that happens when x is equal to negative 0.2. So those are the two equation parts. Now for part C and D, we're dealing with inequalities, looking at those action places, in other words. Part C says, when is this expression 1.2x minus 0.36 greater than 0.6? So remember again, this is pretty much our y from the original problem. So this problem is really asking when is y greater than 0.6. So I gotta go to the y value of 0.6, which was up here, and I have to figure out when y is bigger than that. Well, y is going to be bigger if I go up. So in this region, y is bigger than 0.6, and what x coordinates qualify for that? Right here, all the x's below, it's kind of like as if it were to cast a shadow down on the x-axis. Those are the x values that qualify. In other words, the solution is all the x's bigger than 0.8. Now part D says, when is this statement true? So let's go figure it out in terms of the y's that was given to us originally, the way they defined the equation. Remember, y was equivalent to this expression right here from up above. So I'm going to replace that guy with y, and it says, when is y less than negative 0.6? Again, if you were to say a little sentence, when is y less than? If this y on that side is bothering you, put the y here, put the negative 0.6 on the other side, and then the original statement had the mouth open towards the negative 0.6, so open the mouth towards the negative 0.6. So we're really analyzing when is y less than negative 0.6, or when does this line right here have y values that are smaller than negative 0.6. Well, I'm going to go to the y value of negative 0.6 where I was before, but now I have to pick all the y's that are smaller than that y value of negative 0.6. So if I'm looking at that, all the y's smaller are down below, which means if I go and I correspond it to the x-axis, all the x's to the left of that border, that location, are going to qualify as a solution. So our solution is x has to be less than, it looks like up above, negative 0.2. So without solving anything algebraically, I just pulled all this information out of the graph.